So I was curious, how many distinct bowling games are there? A typical bowling game has a scoreboard that looks like this. You have 10 frames. Each frame has 2 chances except for the 10th frame, which might have a third chance if you get a spare or a strike in these first two. I found something online by a guy named Stephen Klontz. This is his website. He found out there are 66 different ways you can score in a single frame. So for example, 8 on the first chance, 1 on the second, or 2 on the first chance, 7 on the second, or 3 on the first and 3 on the second. And then you multiply it by all the 66 possible outcomes for each frame. And then you find out because the 10th frame has a potential third chance, he figured out that ends up being 241 possibilities. After he multiplied all these numbers, he got 5.73 times 10 to the 18th. This is awesome. He found out all the different combinations of scoreboards you can have. But I wanted to go a little bit further. His 3-3 could be these first 3, and then on your second try, you get these 3, and you end up with this. Or it could be these 3 on the first chance, these 3 on the next chance, and you end up with this. Both of these outcomes, he considers them the same thing. I'm wondering, what if we don't consider the same thing? How many possible games are there in that case? So instead of 66 possibilities per frame, I think there's 59,049 possibilities per frame. And let me explain it. So if we look at the 10 pins, and let's look at this individual pin, it can either be knocked down on the first chance, missed on the first chance and knocked down on the second, or missed for both chances. Well, all 10 of these pins will have 3 possible outcomes. So I think we have to multiply 3 10 times, and that's the same thing as 3 to the 10th, or 59,049. All the first 9 frames are going to be 3 to the 10. So we're going to multiply all these by each other, and then multiply by whatever this 10th frame gets us. So to tackle this 10th frame, the first 2 chances we know are going to have the same 3 to the 10 as all these other frames with 2 chances. Of these 59,049, we know we can either get a strike, a spare, or between 0 to 9. There's only one outcome where we get a strike. That is to get all 10 in the first box. So in order to get a spare, we need to look at all the 10 pins again. Each of these pins either has to get knocked down on the first chance or the second chance. So the number of possible spares we can get would be 2 being multiplied out 10 times, or 2 to the 10th. That's 1,024. And then the number of possible 0 to 9s we can get is 58,024. Now let's figure out how many possible outcomes there are in this 10th frame. If we get a 0 to a 9, we're done. The third frame does not come into play. If we get a spare in these first 2, we're going to get one more chance to bowl. And the number of total possible outcomes for that last chance to bowl is every pin either can be hit or not hit. So we're going to have another 2 to the 10 being multiplied by that. And 2 to the 10 is 1024. And the last thing to look at is if we get a strike, that means we're going to have a chance to bowl 2 more chances. We know that the total number of possible outcomes for 2 chances is 3 to the 10. So we're going to multiply that one by 3 to the 10. And then if we add all these up, I think that's the total number of possible outcomes for frame 10. So we can update this up here. Since we have 9 3 to the 10s, we can rewrite that as 3 to the 10 to the 9. And then we're going to multiply that by the 1,000,001. 3 to the 10 to the 9 ends up being 3 to the 90. And then we multiply these, we get 1.01 times 10 to the 49. So that is the number of total possible bowling games. I honestly don't know if this is right. I could not find this information online. So please let me know if I messed up the math anywhere.